In this video, we will learn a very simple but important concept in the set theory, that is Venn diagrams. Actually, Venn diagram is named after the mathematician John Venn. He started using closed figures to represent a set. For example, consider the set 1, 2, 3. Set of first three natural numbers. Okay, so he used some geometrical figure to represent this set. Closed figure. Okay, 1, 2, and 3. And such representations of set was named after him as Venn diagram. Okay, it's a very simple concept. We have to just use closed figures to represent a set. We will consider another set. Set of vowels. I can use any geometrically closed figure and then I can represent the elements randomly. Okay, so using closed figures to represent a set is known as Venn diagrams. It is named after the mathematician John Venn. So the further concepts in set theory will be much more easier to understand if we use Venn diagram to represent it. Okay, so we will see some few concepts and we will have a better understanding when we use Venn diagrams to understand the definition. First next concept we are going to learn is subset. Okay, consider two sets. Consider two sets A and B. Okay. First I will write an example. The first six natural numbers and consider set of odd numbers less than 6. Okay, consider these two sets. Now if you observe, every element in B is also in A. That means B is a small part of A. So we will call B as a subset of the set A. Now using Venn diagram, how I will represent it? This is my A. Okay, so I will use another small figure within it to represent B, because B is a part of A. So within B I will write 1, 3 and 5, and rest points I will write outside 2, 4 and 6. So this bigger circle represent set A and this small rectangle represent B. B is contained inside A. So B is subset of A. Subset of A. So we will write the formal definition now. I hope you understood the concept. So consider two sets A and B. If every element in B is also an element of A, then we call B to be a subset of A. And how do we denote it? We denote it using this symbol. B is a subset of A. This is the notation. Okay. Now we'll find an example. Okay, do you remember the fundamental number sets? That is set of natural numbers, that is n, and set of whole numbers, that is w. Now natural number starts with 1, 2, 3, 4 and it continues. Normally whole number starts with 0, 1, 2, 3, it continues. So if you observe, every element in n is also in w. So my set of natural numbers is subset of whole numbers. Similarly, if I take integers, and continues still infinite. It is an infinite set. We have already discussed it. So here every element in W is also an element in I. So W is subset of integers. Okay. Now we will learn some facts about subset or some properties of, that every set will follow. Okay. The first property is A is subset of itself. That means every set is a subset of itself, because every element in E is also an element in A. So A is subset of itself. Second such property is null set is a subset of every set. Here A represents any set. Okay. So every set will have null set as its subset. Null set means no element. So no element is a subset of some elements. Okay. Set of some elements. And the third such property is if A is subset of B and B is subset of A. If we know that these both are true, then it will imply, or then A is equal to set B. A is subset of B means every element in A is an element in B, and B is a subset of A means every element in B is an element in A. So naturally A is equal to B. We will try to write an example which will satisfy both the conditions. Okay, every element in A, consider A as now I want to form B. Now every element in A is in B, so this element has to be in B. Okay, now let's see what other elements will be there. And this condition says every element in B is in A. So now in A only 1, 2, 3 are there. So again B can contain only 1, 2, 3. So all the elements match, so these are equal. Okay, and we have already learned the definition of equal sets, and it is the same thing. It says that every element in A is in B and every element in B is in A, then A and B are equal sets. So same definition we can apply over here. Similarly, the converse of it is also true. If A and B are equal sets, then by definition of equal sets, every element in A is contained in B and every element in B is also in A. This is also by definition of equals. Okay, next topic after subset we will learn is universal set. As the name suggests, universal set means it is the largest set in consideration to consideration of our study. Okay, for example, if I am studying, I am to take a record of all students who got 90% and above in standard 9th. Okay, students who scored more than 90% in 9th standard. Okay, now this is the matter of study. Now what I will, so here my universal set will be students of standard 9th. That means all students of standard 9th. Okay, I want to know students who scored more than 90% in standard 9 of some particular school. Then all students of standard 9th of that school will be my universal set, and the students who scored more than 90 will be subset of that universal set. Another example is, I want to form a 11-player cricket team in my locality. I want to form a cricket team of 11 players. So now here my universal set will be all the players cricket players in my locality. Okay, I want to form a 11-player cricket team in my locality. Then the universal set will be all the cricket players in my locality, and from them I will choose 11 players. So this will be my universal set, and this will be subset of the universal set. Since the universal set should we will denote it using U. Okay, and this is a subset. That means A is subset of universal set. Now this rectangle I am denoting for all the cricket players. That is a universal set, and within that it's a small subset of 11-player team that I made, that I have chosen from this set. Okay, this is A, this is U, and this is A. So this is the concept of universal set. So universal set means the largest set in terms of which you are forming a subset according to the given condition. Okay. Now consider other example so that you will get a better understanding. Now when I write set of, A is set of first 10 natural numbers. Okay, first 10 natural numbers. So here, which is a universal set? It is the set of all natural numbers. That is the set of natural numbers, n. So my universal set is n, and my subset of the A is subset of this set. So the largest set which I am talking about is the natural set of natural numbers. From that I am picking up just the first 10 natural numbers. So that is a subset of the universal set of natural numbers. So A is subset of universal set, that is a set of natural numbers. Okay. The next concept is complement of a set. So consider, okay, let U be universal set. Let B be subset of U. Means B is contained in U. All elements in B are also in U. Then set of elements in U that are not in B. The set of elements in U that are not in B, that are not from B, is called complement of B. Complement of B, and we denote it as B dash or B complement. Okay, these are the notations used. We will take one example. Consider U and then B to be set of odd numbers, 3, 7. Then what will be B complement? B complement will be a set of all those elements which are not in B but in U. That means elements in U. 2 is an element in U and not in B. Then 4 is an element in U and not in B. 6 is an element in U and not in B, and 8 is. So when I took B to be set of odd integers, I got B complement as set of even integers. Oh, even numbers in, sorry, not integers, in numbers in the particular universal set. Now how do I represent it using a Venn diagram? So I will represent, this is my set U, okay? Or maybe I'll write it outside, because I will require this space to write. This is my set B, which is subset of U, which has 1, 3, 5 and 7. Okay, 4.7. So outside it I have 2, 4, 6 and 8. So if this is B, then the outside part should be B complement, or we can denote it this like this, B complement. This whole thing is U. Within the circle there is B. Within the circle it represents B, and outside this circle and within this U we have B complement. Is that clear? So complement of a set, the set of those elements which are not in it but it is in its universal set. Okay, now just like we had some facts or some properties related to subset, similarly for complement of a set also there are some few things that we are supposed to know. Okay, One thing is, the first property is a set and its complement, that is B and B complement won't have any element in common. It's a simple logic, right? Because I am choosing only those elements which are not in B. So obviously there should not be any common element between B and B complement. Similarly, second such property is my B. This B is subset of U. The same way B complement is also subset of U. The third property is, okay, we'll see what will be the complement of the universal set itself. Is equal to what? U complement is equal to. That means, suppose this is the universal set, this whole thing. That is 1, 2, 3, 4, 5, 6, 7, 8. First 8 natural numbers. Now, what will be the complement of it? It is null set. There is no element which is outside of U and within U. How can be it possible that the element is not in U and the element is in U? That means it is null set, okay? Similarly, phi complement. That means complement of null set. So null set means in place of B we have null set, no elements. Then what is the complement of it? Then all elements will be outside B, right? Okay, this is a null set. No elements within it. Then all other elements have to be outside it. So it is a whole U. So phi complement is U. These are few facts about complement of set. So complement of an empty set is universal set itself. The complement of universal set is empty because there are no elements other than outside of universal set and still it is inside universal set. So it should be null set. And here also it is. So these are the 4 properties. Okay. So we are done with the 3 main topics. No, actually we started with Venn diagrams and then we learned subset, universal set and complement of the set. Using these 3 concepts we will practice 1, 2, 3. So that I will do in the next video. Stay tuned. Thank you.